All right, so given that we're coming up on galaxy season, and if you're new to the hobby, kind of the summer is nebula season, and then winter gets into be open cluster transitioning and globular cluster, and now we're in the spring. You come into galaxy season where all the galaxies start to come up. So I thought we'd go over M106, which is a really great galaxy, both for visual as well as for astrophotography. So M106 is used sometimes overlooked because there's so many good ones around. For instance, M51, which we had a nice presentation on. And if you look up over here where my cursor is, you have M101, which is a beautiful spiral galaxy, and a couple more here down in Canis Venatici. I always have trouble pronouncing that. But M106 is kind of a bit of an unusual spiral galaxy, and we'll get into the details of that in a little bit. So just as far as observing it, M106 has a high surface brightness, which is great because it means you can see it, right? So if it has a low surface brightness, it's really hard to see in smaller telescopes and binoculars. But under a dark sky, you can even pick out M106 in binoculars. Now, it doesn't have a lot of detail, but you can see a little fuzzy patch at least. Now with a small scope, you can see a kind of a diffuse patch, and it has that bright center. So you're seeing the core of the galaxy with it. And then if you have an 8-inch scope or greater, you can be able to see some of the structure of the spiral. And even larger telescopes, you can see the spiral arms in detail. So I asked Jack Kramer, who was a member here for many years, and he keeps great observing logs that he's recorded all these through the years. And this is what he had to say about observing it. It's a large, prominent galaxy that shows a band of brightness running along the major axis with a nucleus slightly offset, and we'll talk a little bit about that in a second, from what would appear to be the actual center. And this impression is confirmed in photographs. He's never observed it in anything smaller than an 8-inch scope, but at magnitude 8.4, it should be visible, and indeed it is. So a little bit of science around there, and I got some of this information from a really nice website for the Messier catalog. It's messierobjects.com. And it has some really fantastic information on each of the catalog objects. So it was discovered in 1781 by Pierre Marchand, a French astronomer. And I think a lot of people really aren't familiar. They think Messier discovered everything, but he just cataloged it. A lot of the objects in the catalog he did not discover. And it's the largest member of the Canis Venatici group, Venatici 2 group, which we'll show right here. So M106 is up here, and lots of other galaxies in the group. It's classified as a SBBC. So you're asking what the heck is that, probably. And I'll try to help you understand it. So there's really 3 different kinds of galaxy types. There's elliptical, there's regular, and then there's some sort of spiral. So in this case, M106 is a spiral that's kind of in between the SA and SB. So it doesn't have the bar going across it so much, and it's just a combination of those two, basically. You can get more technical with it, and I'm sure some other people in the club could probably nail that down better than I could. But anyway, it's an intermediate between those two. So what I think is really cool, especially when you're looking at galaxies through an eyepiece, is you're looking at in this case approximately 400 billion stars, and I don't know. I've been in this hobby a long time. That still blows my mind. Some other term I really wasn't all that familiar with, but when researching it, it's known as a Mazar galaxy, which is a microwave amplifier by stimulated emission of radiation. So there you go. So I'm just reading to you what I've researched. This is not coming from my great knowledge base. So a Mazar is a microwave laser, or a laser that operates in microwave instead of visible light on a galactic scale. The nuclear mega Mazar ring is responsible for M106's purple color. So when we don't see the purple color, but when we image it, it tends to have that purple color. So, but that's why it's there. So the unusual emission lines and X-rays are shown in this combination picture from a bunch of different groups, which I think is really cool. And if you notice, when we look at the visual, what we see in our photographs, it's kind of cluttered around the center, and it doesn't have that real defined spiral arms near the center. And this is the reason why, is you have this X-ray happening here, activity. And in this photo, there's very little optical showing because that's in the gold. But in the infrared and radio, this is a very dynamic, spiral galaxy, and that's why it's so unusual, at least to me. One other thing, the X-rays indicating that a portion of this galaxy is falling into a supermassive black hole. So when I'm talking about this unusual structure around the center, this is the reason why. It's this X-ray portion that's really kind of making this hard to see, hard to see the spiral in it. So here's a composite image from NASA, the European Space Agency, and it was actually processed by two really well-known amateur astrophotographers, Robert Gendler and Jay Gabbani. But I think this is pretty cool, and you get to see, these X-rays, portions of it coming out. Okay, so what's neat about this from an photography standpoint is it's not beyond the reach of basically anything we throw at it. Anything from the revolutionary imager to the DSLR to the dedicated astronomy cameras. This is an image I took of the region in March of last year. It was with a Canon 6D and 63. It's a bunch of different subs. Some at 1.5 minutes, some at 1. So some very basic calibration, and at the time I was processing it in Sequator, and probably processing pretty similar to what Walter went through. So here's a little bit of a zoom up of it. So there's the purplish color, coming out. But what I think is really amazing at, some of the stuff that we can take is not just, M106 here, but these little two guys here. They're 333 million light years away. And that I don't know, that just blows my mind that we can do anything to capture that kind of detail. And then sometimes there's some strange things that show up in your photographs, not just the catalog items, but this is something I did. I actually was holding the ears of the target dog when it took this original picture, and I thought, oh, this would be fun to put this around M106. Anyway, so that's your comedy for the evening. So, like I was saying, you get the brighter galaxies, but all those little PGC annotations in this image are also galaxies. And I've tried to look up some of these, and they're not even cataloged as to how far away they are. Some are, but most aren't. So they just haven't even taken the time to figure it out or whatever. But it's just amazing that we can see this many galaxies in a photograph that we can take, from here on Earth. So here's my most recent image of it. This is from the 23rd of January. The scene was pretty bad. I'm shooting from a bright part of Batavia, so it's border late here. And so roughly it's, about 5 hours of time I took on it. And you can start to see some of the detail and even the smaller galaxies in it. But what I think is really cool, oh yeah, here's one that is just a little blown up. But what excites me is some of the pictures that Mark, both Marks took, but particularly Mark Christensen, because it tells you what kind of things we can do when even in the worst of circumstances. So this one is I pulled off his Flickr account, and it's from May of 2012, and it was windy. He's got a Newtonian, so it tends to be a little bit of a windsock, but you can still get a pretty decent picture from it. So that's with an 8-inch f5.5 Newtonian. And here's one that Mark Wagner took from February 22nd of 2017. He's gone through with his mono CCD camera, taken through filters. Anything you want to add to that one, Mark? He's got it printed out, so he's pretty happy with it. All right. Okay, this is the one that I thought was amazing, because it's a half hour of data, and this is Mark Christensen's again from April of 2013, right from his backyard. 30 minutes to get something that I think is absolutely amazing kind of detail on a galaxy like this.
Yeah, this one I took with the DSi Pro and the 11-inch Celestron. This is a long time ago.
Oh, okay. But that's beautiful too.
Yeah.
Yeah.
But just like you said, the shape of the galaxy, and then when you put the different wavelengths together and you try to understand what's going on with this thing, it's unbelievable.
Yeah. So
this shot here was actually, I'm like Walter. I've got trees all around me, and I have an obstructed view of Polaris. So I have to time what I want to photograph very carefully to be able to get any kind of an image.
But to get the kind of detail in the arms that you got here, I think is really incredible.
Yeah, I know. Yep. Going back to the bad old days of film and manually guiding these things.
Yeah,
it's a miracle what we can do now.
All right, so we're coming to the end here. Just again, how you find it, if you know where the Big Dipper is, you got a really good shot. You can star hop any which way, but if you start at the bottom of the bowl and just come down a little bit, it's really not too hard to find. Just casually mention one of the ways I used to star hop to M101 was, this being almost an equilateral triangle on the last two stars in the handle. So when I was back in my star hopping days, that's how I'd find it.
So Andy, I just wanted to say one thing. The M51, M106, M63, M94 are all in the same 8.0 to 8.8 magnitude. So all four of those are very good targets.
Yeah.
Visually or photographically.
Yes.
Right. Yeah. So I'm going after M63 next. That's next, and then
that's another good one. That's another real good one.
Yeah. And then M3 is also on my hit parade again. So.
Yeah, and those are all for everybody else that doesn't know. Those are all coming up in the spring. Right now,
Yep.
right now they're sort of at like 1 a.m. They're up in the northeast. So in another month or so, they'll be very well placed to observe earlier in the evening, away from the sky glow
Sky glow, right?
Which is not just Chicago; it's all the suburbs too. People
Yes.
like to talk about Chicago, but it's all the suburbs in between too.
Right. And you
one more, Andy. The 4631. That's the Whale Galaxy.
Yeah.
So that's a huge edge-on barred spiral.
Yeah.
Magnitude 9.3. It's bigger. It's wider than M51.
Yeah.
So that's another good target. So in this area, there's tons of them.
Yeah. And the one Herman showed tonight, the owl and the surfboard, is somewhere in here too. I forget where it is, but it's in
the owl is up by the upper right-hand star of the bowl of the Dipper.
Yeah, that's what I thought. It's right up here. Oh yeah, it's right here, right?
No, that's Alpha. Just drop right down. Beta, yeah, it's there.
Okay.
There.
Yep.
In fact, that little cross with a green circle, that's the symbol for a planetary nebula.
Oh yeah, right. Good.
That's M97.
Yeah, very good.
Yeah, for those who don't know, when you're looking in that general region of the sky, if you look at where it says Coma Bernaces, that's the pole of our galaxy. So you're not looking through all the dust and gobbledygook and nebula of our own galaxy. You're looking almost straight out into intergalactic space. That's why there's so many little red dots there. That's because that's where you can see the galaxies more clearly there, because you're looking perpendicular to the plane of the Milky Way.
And so visually, you have the Virgo cluster that gets a lot of publicity, but this area is just as rich in visual, and just that the galaxy hop between these is a lot of fun.
And don't forget too, it's nearly circumpolar, so it means we can see it. If you got a clear view of the horizon from the north, you can almost see this stuff year round.
Yep.
Yeah, but prime time is coming up in the next month or two, so this is good preview.
Yeah. So here's my encouragement to everybody. So if you're a visual observer, go out and observe it and give me a report for the newsletter. if you're an astrophotographer, give it a shot and see what you can come up with.
Yeah, and M3 is one of the brightest and largest globular clusters in our skies.
Yeah.
Yep.
I mean, M13 gets all the press, but M3 is pretty impressive.
Yeah, sure is. Yeah. And again, you can use Arcturus as a star hop too, because that's right here. It's very bright, very red.
Yeah.
Easy to find. All right, I think that is it. Any questions?
All right. Another great meeting so far.